Are we going to mine the oceans or outer space first? Right now, neither has begun, but both are closer than you might think. The first deep-sea mining machines could be crawling across the Pacific seabed within just a few years. At the same time, small spacecraft are already being sent out to test whether asteroids and the moon can give us the resources we'll need in space. So which will come first? The crushing depths below, or the endless void above? The deep ocean is still the least explored part of our planet. Down there, in total darkness and under immense pressure, lie fields of strange potato-sized rocks called polymetallic nodules. They're loaded with metals we rely on: copper, nickel, cobalt, manganese, the same ones that go into batteries, wind turbines, and electric cars. And it's not just nodules. Around hydrothermal vents you'll find chimney-like towers rich in copper and gold. On underwater ridges, hard crusts full of cobalt and platinum. Together, the seabed could hold as much metal as all the known deposits on land. That's why companies are circling. The metals company has already tested robotic harvesters and wants to begin production by 2027. Norway has cleared exploration in its waters. China has licenses. Others are building prototypes. Deep-sea mining sounds close. But the risks are huge. Stirring up the seabed could send plumes of sediment drifting for miles. Entire ecosystems around vents could vanish before we even study them. Even carbon that's been locked away for millennia might be released. And then there's the question of rules. The International Seabed Authority issues exploration licenses, but it still hasn't agreed on how commercial mining should work. Some corporations like TMC aren't waiting. They're turning to US domestic law to push ahead. So, on the ocean side, the pieces are lining up. The technology exists, so the pressure is building. Now let's look up. Beyond Earth lies another frontier, equally rich in resources. Asteroids contain nickel, iron, and platinum group elements. Some are so metal-rich that even a small one could outclass Earth's annual output. The moon holds water ice in its shadowed craters, enough to turn into rocket fuel depots. Its regolith even contains helium-3, a theoretical fuel for fusion reactors. Mars has oxygen, water, and construction material locked in its soil and atmosphere, essential for any long-term base. But here's the key difference. Space mining isn't about shipping metals back to Earth, at least not yet. It's about in-situ resource utilization, using resources where they are found. Turning lunar ice into fuel, using Martian regolith as building blocks, capturing asteroid material for orbital industry. Small steps are already underway. Astroforge launched a refinery test. Kármán Plus plans excavation trials in orbit. Transastra is experimenting with optical mining, using concentrated sunlight to break apart asteroid rock. And NASA's Psyche spacecraft is on its way to study a giant, metal-rich asteroid. The challenge? Every piece of technology is experimental. Anchoring to a rock in microgravity, mining without air or water, processing ore with a 20-minute signal delay, all of it is unproven. Unlike seabed mining, which borrows tech from offshore oil rigs, space mining has to build everything from scratch. So, in terms of readiness, the oceans are closer. But in terms of vision, space is the bigger leap. Banks are quite hesitant about seabed mining, and that's not just because of environmental risks, but because the rules are still unclear. On land, projects are easy to analyze. We know the tech, we know the risks. At sea, it's all unknowns. Space has the opposite problem. The resources are there, but bringing them to Earth doesn't make sense financially. So the real payoff is in cutting the cost of exploration. Turning ice into rocket fuel could save billions. That's the prize companies are chasing. Public perception matters too. Seabed mining often raises alarms because of the potential damage to ecosystems we still don't fully understand. Space mining, on the other hand, is looked at more positively, adventurous, even visionary. But that doesn't mean it's risk-free. Both paths carry consequences, even if one is easier to accept. The truth is, we're getting closer to both possibilities, faster than most people realize. Within a few years, mining machines could be working on the seabed, and before long, spacecraft may start turning lunar ice or asteroid rock into the building blocks for life in space. So the real question isn't whether we'll do it, it's where we'll begin. Do we dig into the oceans first, taking on the risk of changing an environment we still don't fully understand? Or do we turn outward to space where the challenges are greater but the prize could be even bigger? Whichever comes first, it won't just be about resources, it'll be about what kind of future we choose to build. So what's your bet? Oceans or space? Share your thoughts below. Like this video and don't forget to subscribe for more space news.